So yes, my dear friends, Bhuvanesh Oza again at your service. We are trying to learn power system protection fully. We have learned the transmission line protection by overcurrent and earth fault relays, distance relays, and line differential relays. Then on, we have started generator protection. And we have learned only one kind of protection, that is differential protection, and that too for double line and triple line fault. While talking on generator differential protection, we were talking about that it is for the failure of insulation of stator winding. I had forgotten to tell you the causes, but the causes are very obvious. One cause is overload. If you overload the generator, that means if the generator is working at 9050 ampere and if you go to 9100 or 10,000 or 11,000 ampere, then the temperature of the winding will increase. And if the temperature goes behind the Wissant temperature of the insulation, then the insulation will be damaged and the fault will occur, double line or triple line. But you see, as I was telling to you, that in one slot, only one conductor is placed mostly, or even if two conductors are placed, two conductors of different phases are never placed in the design of the generator. So the fault in the slot is just not possible. If at all it is possible, as I was telling, it was in the overhang portion. And once again, overload is such a small and unimportant thing. Unimportant means it's not so that it is completely unimportant, but as far as I am concerned, say I am in charge of one particular generator, I have to simply throttle the steam control valve of the turbine and reduce the load on the generator. So I am saved. My generator is saved. That is one reason, overload. But yet the second reason is failure of ventilation system. If ventilation system fails, then also the overload, that means the temperature will increase, and increasing the temperature will cause the failure of insulation. Therefore, as I was telling to you, the stator conductors are hollow, and through the hollow, the distilled water is run, and flow, pressure, and temperature at the inlet and exit both are measured continuously, non-stop, every moment. And if anything goes out of order, then alarm is sounded. So the person in charge will take actions. So that was what I was trying to tell, that double line and triple line fault are more or less next to impossible, right? So overload, ventilation system failure, and over voltage. If power frequency over voltage or high frequency over voltage surge comes, then also the insulation can fail intrinsically. But for that, we are keeping the surge arresters near the generator. So we are taking all protective actions. But yet, it is not so that we are not protecting. We are protecting the generator by differential protection, and that we have studied. For earth fault protection also, the causes are the same causes. Overload, ventilation system failure, or over voltage, same causes are there. But the differential protection cannot protect the earth faults. But before we talk about earth fault, let us talk about interturn fault. I mean, interturn fault means fault between two turns of the same phase. Now try to understand that even if two conductors of the same phase are in the same slot, then also it will not be first conductor and 10th conductor or 11th conductor. It will be first conductor and third conductor. I mean, it will be first conductor and fourth conductor. So the current in that parallel path will increase. Say 4500 is there. Then instead of that, in one of the paths, it will be 5000 ampere or more. So it will be a little more. And it is the fault between two conductors of the same term. So it will be a local hotspot, nothing else. So interturn fault is not dangerous to the generator. Generator can keep on running, can deliver the power, no problem. But we are not taking it easily because that hotspot will go on increasing the temperature and it may turn into line to ground or double line fault. I mean, that is quite possible. So instead of allowing interturn fault to result into LG or double L fault or double LG fault or anything, we should detect the interturn fault itself. Unfortunately, the differential protection here, it is not shown. The CTs of differential protection are near the neutral end and line end. The current incoming and outgoing is yet the same, however the interturn fault has occurred. So differential protection cannot detect the interturn fault. We will have to have a separate interturn fault protection. So it is basically a differential protection. It is known as transverse differential protection. CTs are cross-connected on both the parallel paths as shown. Right. If there are no parallel paths, means if there is no double star winding, then also there is a method, but that is very rare, so I am not taking. But this double star winding, you can see that if interturn fault occurs in one of the parallel paths, then in that path the current will increase. And that will lead the flow of current through its GIR, GIY or GIB. Otherwise, both the currents are same and no flow of the current through its GIR. GI means G means generator, I means interturn, R means R phase. 87 is the number for differential protection. It is an internationally known number. Anybody in the world, if you say 87, will understand you are talking of interturn fault protection. And once again, for external fault, there is a possibility of maloperation, possibility of instability. So our step and the calculation of our step is similar. Everything is similar. This is differential protection. Here also we have kept surge diverters to bypass the high frequency surges, the noise, right? So that it's in JR, JY and JB are rather prone to, or they will operate only for fundamental frequency currents, right? So interturn fault protection is simple, but yet because it is going to result into very severe fault, line to ground or double line. Therefore, this is also instantaneous and class A protection. That is for your information. So simple protection, nothing difficult, same, all calculations, methods, knee point voltage in the cities, knee point voltage requirements, everything is same. No doubt, we are going to talk about CTs in detail afterwards. So then we come to the earth fault protection. As I told you, the earth fault current is very low, is kept very low. So one way of stator earth fault protection is this REF. the connection for REF generators are usually star connected, double star, not shown, but you have to understand. We connect one neutral CT. Line CTs are shorted and relay is connected. No doubt stabilizing resistance also we will connect. Not shown here, but we will connect. And a resistor or a reactor, anything. Now, we'll take one example to show what should be the value of resistor, what should be the value of the earth fault current for the terminal earth fault, and for what sensitivity we are talking, what sensitivity of the relay we are talking. So if we talk and we want to conclude that this REF protection for large generators, 120 megawatt, 210 megawatt, 500 megawatt, 660 megawatt is useless. This cannot be used. We want to prove that. For proving that, I am showing this. So we are taking an example 11 kV, 3 phase, 30 MVA. Small generator we are taking, starting from. Star connected alternator is protected by an earth fault relay having 10% setting. That is, sensitivity is 10%. If the neutral resistance limits the maximum earth fault current to 40% of full load value, 40% of full load value probably will not damage the stator winding, will not damage the stator core laminations particularly, because you see we are more worried about stator core laminations, because the insulation between the conductor in the slot and the stator which is grounded is failing. Therefore, the earth fault current is going to flow through stator core laminations, and the varnish between the laminations is going to be damaged, then the laminations are going to be shorted, thereby the eddy current losses will increase and the generator will overheat. That is our main problem. So we want to limit the earth fault current to as low as possible. Here we are trying with first 40%. Determine the value of the resistor and percentage of the winding protected. That is another disadvantage, that we will not be able to protect full winding. And that is what we want to prove. Find also the value of the earth resistor needed to allow only 99.5% of the winding to be left unprotected. Means if you want to protect more percentage of the winding, 100% you can never protect. That also we will see, right? But then if you go for 9.5%, then earth fault current will increase. And the possibility of damage to the stator laminations, stator core laminations will increase. So this is the difficulty. CT ratio 11 kV, 30 MVA, if you consider, the current is nearby 2000 ampere. I mean, you can calculate 0.85 PF you can assume, because usually generators are designed for 0.85 PF, so 2000 bar 1. So full load current of the generator we find, maximum earth fault current we find. So full load current IF max is 1574.6 into 0.4, 629.8. That is 40% is given. Into sign is forgotten. So please correct. 629.8. 1574.6 multiplied by 0.4. The value of the earth fault current can be found by equation. So this can be found. This is just so we are finding what is full load current, 30 MVA into 10 raised to 3 divided by root 3 into 11, 1574.6. That is why we have considered 2000 bar 1 as CT. I think 2000 bar 1 or 2000 bar 5, 2000 bar 1. It can be possible. Yes, 2000 bar 1 we have considered. maximum earth fault current, that is the current for earth fault is 1574.6 into multiplied by 7. Once again forgotten here, 629.8. So what is this earth fault current? That is 3 EPH upon Z1 plus Z2 plus Z0 plus 3 Zn F max. That is Zn we have connected in the, deliberate impedance that we have connected. Now, that deliberate impedance is so high that you can forget Z1 because Z1 is hardly 0.2. I told you 20% or so. So 3 EPH upon 3 Zn F max. So it will be EPH upon Zn F max. So if you consider EPH upon Zn, then it comes out to be 629.8. And that is what we have calculated. 629.8. That is 40%. That is what we have already calculated, right? Rn 629.8 we know because 629.8 we want to allow. So for that, what should be the value of Rn? 629.8 we have already calculated. So from this equation, Rn should be 10.08 ohms. Now for this 10.08 ohms, what percentage of winding will be protected? If I say that P% will be unprotected from neutral, then 11 by root 3 into P into 10 raised to 3 for converting kV to voltage divided by 100 and into Rn, then it comes out to be 6.3 P ampere. And for this 6.3 P ampere, 6.3 P ampere is what? It's the sensitivity to get P. Sensitivity is 10% of 2000 ampere because our CT, all CTs are 2000 bar 1. Try to understand. In so to say this restricted earth fault protection, all CTs, line CTs and neutral CTs, all CTs are 2000 bar 1. So our value of the this 10% of 2000, if I consider in primary amperes, it is 200. So P is equal to 31.74. 31.74% winding will remain unprotected. Only 68.26% winding will be protected. Nobody will look after that 31. If the fault occurs, earth fault occurs in 31.74% from neutral, nobody will protect. No relay will protect. This is not at all allowed. This cannot at all be allowed. This is not a protection practice. Right? And if you want 9.5% of the winding to be unprotected, your Rn comes out to be 3.016. You will have to connect low Rn. But the problem is then IF max, that is the fault current for the faulted terminal, will be 2105.72. That is 133. Roughly 130% of the full load current. So possible damage to the stator laminations is increased, right? So this is a problem. You are caught into a vicious circle. That is what is happening. So that vicious circle is very clear in this table. If I keep relay sensitivity 10%, with which we have started, 10.08 is the neutral resistance. 40% magnitude earth fault current, not harmful. But then quite a lot much of winding is unprotected. If I want only 9.5% winding to be unprotected, then I have to do at the cost of more earth fault current. That is the possibility of damage to the stator core laminations. If I do not want to do that, and if I limit the earth fault current to only 10% of the maximum earth fault current, then no winding will be protected. Nothing will be protected. Even up to 12.7 ohms of the magnitude of the earth fault current, no winding. 100% winding is not protected. earth fault will not be sensed. You will not be able to sense the earth fault by REF, right? And if you want only 5% of the winding to be unprotected, then you have to allow 255% of the rated current. That is roughly 2.5 times the current you have to allow to flow through earth fault. Stator core will be certainly damaged. So you are caught into a vicious circle. Yes, you can increase the relay sensitivity. You can improve the relay sensitivity, but there is a limit to relay sensitivity because the normal capacitive currents will be nearer to that sensitivity. You see, if you go to 1% or 2%, so better than 5% is never possible. So in 5% also you are caught into same problem. You see, if you see the table, you are caught into the same problem. The the conclusion is REF protection cannot be used to detect the earth faults in the generator. We look at this problem from another angle. You see, very, very important analysis to see, to prove the futility of this kind of protection, that is REF protection. We take simple 11 kV 0.8 PF generator and we vary the megawatt rating 5, 10, 20, 30, 40, 50, 100, 120. And so you can go on increasing. Usually 11 kV means 120 megawatt. Then if you go for 210 megawatt, then you have to increase the voltage because otherwise the current will increase. But anyway, if you see this simple analysis and we consider constant neutral grounding resistor 10 ohms and sensitivity we keep best 5%. If we do this analysis and the formulas are known, full load current is megawatt into 10 raised to 3 divided by root 3 into 11 into 0.8. 0.8 is the power factor we assume. For terminal earth fault, it is 11,000 by root 3 into 10 because 10 ohm is the neutral grounding resistance. Sensitivity of the relay is P into 11,000 root 3 into 10. And therefore, percentage winding unprotected you can calculate. If you do this analysis, very important analysis, if 5 megawatt generator you are protecting for this case, 3.93% winding is unprotected. Not bad, not that very bad. But for the same thing, we go for 10, 5%, for 20, 11.8%, for 30, 15.75%, and for 120, 78.73% winding is unprotected. Roughly 3/4 of the winding is unprotected. So this is another way of statistics to show that REF protection is useless. You cannot go for REF protection. To detect the earth faults, you will have to go for some another method, right? So that another method we will not see today because otherwise the length of the video will be large. Today we are only concluding that REF protection is useless. That is what we are concluding. And with that conclusion, we end our talk for the day. These classes will be popular because you see, I have not seen teaching power system protection in this way. The credit does not go to me, credit goes to great grand guru of mine, Dr. Madhav Anant Date, who is no more now, died in 2002. I remember him every moment because he was a gem of a person. And as far as I have seen the teachers, I have yet to see the teacher of his cadre. So this knowledge is coming from a very learned personality, not me, my guru. I learned from him and I am conveying to you. So if you convey to as many friends as possible, then this education, this uh, this learning, these tuitions, this knowledge will go to more and more people, and more people will know Adapt Me. Adapt Me is trying to do that. And through Adapt Me, I am conveying the knowledge of my great guru. There is no equivalent subject, I mean equivalent word for guru in English. Guru is the word coming from Indian culture. People say master in English. If at all you want to go little nearer to guru, then it is master. It is not teacher. Dr. Date was not my teacher. Teacher and student is different. Master and disciple is different. Dr. Date was my master. I was his disciple. I was following him fully. And therefore, complete knowledge, more or less complete knowledge, which he had, he could transfer into me because I was tuned with him. So please, you also, I would request you also, please stay tuned with Adapt Me. So your knowledge will also increase. I want to share knowledge. I don't want to keep the knowledge of Dr. Date with me alone. I want to share it to the whole world. Whosoever wants to understand, whosoever wants to learn power system protection. So please share. अपने पास मत रखिए. Don't keep it with you. Share with as many friends as possible. So with that, thank you, my friends, and good day.